Another application of rational equations is minimizing dimensions. And in the example that I gave, page 234, number 35, what we're going to do is minimize perimeter. So we look at a rectangle that has an area of 182 square feet, and x is going to be the length of one side of the rectangle. What we want to do is change the size of this rectangle so that it has the least perimeter, but the maximum amount of area for that perimeter. So we are going to first create an equation where the perimeter is a function of the one side, x, and then we're going to find the dimensions that give us the least perimeter, and then we're going to find the perimeter by substituting that value into our function. Okay, so let's start by looking at the rectangle. And so any rectangle will work. And I'm just going to call one side x and the other side y. And of course, perimeter is found by 2 times x plus 2 times y. Now, we only want one variable in our function, so we also want to use the idea that we know the area, which is length times width, or x times y in our case, is 182 square feet. So we can use that to eliminate y from the equation. So we can see that y is going to be 182 divided by x. So we'll substitute that in our perimeter equation. So the perimeter is going to be 2x plus 2 times 182 over x. You can see we've created a rational expression there. So for part A, our perimeter is going to be 2x plus 364 over x. So that's part A. Now in part B, they actually want us to find that perimeter and make sure that it's the least perimeter. So for this, what we're going to do is we're going to put that in our graphing calculator and find a minimum value that works. So I went ahead and I already put it in the graphing calculator, and you want to make sure, you can see it's right there, you want to make sure that you set your window to show you where there's a minimum, because it's not going to look like a polynomial minimum. It's going to look a little different. So what I did is I set my x scale from 0 to 50. I eliminated any negative values because you can't have negative dimensions. And I chose 50 because I thought about what would be about the largest length one side could be. And there's no way it's going to be 50 or anything bigger than that. So I used that as a nice round area. I counted by 5s. And then I did the same thing with the perimeter. I chose 300 just because I knew it would cover any value, and I counted by 10s. So now when I look at the graph, what I see is this part of the rational function, and you'll see that there is a minimum section there. So I'll use that feature of the graphing calculator. Now if you have an Inspire, it may, when you just graph trace this, show you where that minimum value is, but it might not because it's not technically, in the purest sense, a minimum. So you might have to use the feature to calculate your minimum. So on an 84, you hit second trace, and you choose number 3, minimum. And then I just need to be the left and right of that. So I'm going to move that cursor over. Keep moving it over till it's on the left side of that minimum point. So I want to make sure I'm way over there. That's definitely not the minimum there. I hit enter. And now I want to move to the right of that. So I'm going to move way over here. And I can see it's going back up the x value, so I hit enter. And I hit enter again. And I can see that it's giving me a minimum value of 13.49 with that would be the perimeter of 53.96. So I have my answers to part B. So from the graph, I get a length of 13.49, and that would be feet, and the perimeter is going to be 53.96 feet, and that's going to be the answer.